So, and it'll be true before the iteration, and it might change, but then it's going to be locked in again. So it's always true before each iteration. Okay, so let's take a look at this. Now, look at the postcondition. The postcondition says that sum will be all the elements added together. Now, I'll give you a very important clue, and this is important that you write this down. The loop invariant will always be a generalization of the postcondition. The loop invariant will always be a generalization of the postcondition. Whereas the postcondition is true after the last iteration, the loop invariant will be true after the last iteration, but it will be also true before the first iteration, before the second iteration, before the third iteration, after the third iteration, after the second iteration. So the loop invariant will always be true. So the loop invariant, how can you, so you cannot have the postcondition be true. You can't say before the first iteration, sum is going to be the sum of all elements. It's nonsense. But what you're going to say is the loop invariant will be based on a variable of iteration. Okay, so let's see what this means. So look what I have over here. I start I as my index equal to A, which by the way is the bottom index of the array, and I initialize sum to 0. Now here is the key that you have to look at, and that is the loop invariant must be true right here, because this is the loop in here. This is the loop. So loop invariant must be true right now before we ever start the iteration. Now notice that we are summing the elements inside the loop. So we say sum is equal to sum plus a sub I. Now look at I, it's equal to a. So in the first iteration, I'll be adding the first element into the sum. Correct? Okay. So since the loop invariant must be true here, I have not added any elements yet, but the loop invariant must be true. So therefore, I will kind of show you the idea here. So the loop invariant is going to look like this. Find the loop invariant. So the sum is going to equal to, as an index j goes from a to I minus 1. What is the value of, look at the first, before the first iteration, what's the value of I? The value of I is a. How many elements have we summed? None. None. So therefore, the upper index cannot be equal to I. In order to have 0 terms in a sum, the upper index has to be smaller than the bottom index. So therefore, if the top index is smaller than the bottom index, there are no terms, therefore the sum is 0. Okay, so therefore, j is equal to a. What's the value? So a is the first index. What's the value of I before the first iteration? What's the value of I before the first iteration? A. So therefore, what is the value of I minus 1? It's a minus 1 before the first iteration. So therefore, before the first iteration, a sub j equal to sum. Sum has 0 terms. Therefore, a summation of 0 terms is 0. Now, think very carefully. What is the value of I before the second iteration? So we did this iteration. Now, what's the value of I? A plus 1. So listen very carefully. So since the value before the second iteration, the loop invariant must be true, the value of I is a plus 1. Loop invariant says sum is equal from j to a plus 1 minus 1, which is a to a, which is, that means before the second iteration, sum includes the first term. Get that here? What is the value of I before the third iteration? A plus 2. So before the third iteration, we would like to have the first 2 of them completed in those 2 iterations because we're entering the third iteration. So here we have a to a plus 2 minus 1 is a plus 1. So a to a plus 1 is how many terms? 2. From a to a plus 1, you're going to add, you're going to get the sum. So that's the loop invariant. And I'm going to come back with this, we're going to finish up next week. But you certainly have enough stuff to do to work on your homework to finish this up. I don't think we have anything, right? Okay, so we don't have anything with iterative proofs, right? We might add something. So the thing I'm going to look for is, but I don't think I'm going to do it for this homework. You have enough to work on. Right? Okay, so I don't need to give you any more work. But we'll pick up with this. So work on the homework, do a super job, make sure everything is done on Microsoft Word. There's an equations editor in Microsoft Word. Anybody have a problem with that?
There's an option to do Google Docs, is that okay?
To do what?
Do Google Docs? Is this kind of like, just have the same equation and everything?
Yeah, so I think so. Let's try it. Let's see how that works out.